record this. Normally I don't record my warm-up, so I'm going to record this. So everybody says I'm going to highlight it in blue. I'm going to work with it in blue ink. This they want to make 1 over negative 2 x to the 5th, y to the 3rd, z to the 8th, all now to the positive 2. Yes? Everyone's happy with that? Now, what math is happening right there? Multiplication. Smurfly correct. So this is all over 1, isn't it? So doesn't that mean this could just move to the top of here now? X squared, y minus 8, z 12, all cubed. Does everybody understand the move I just made there? Right? Because if you do 1/2 times 3, that is 1 times 3, 2 times 1, it's 3 over 2, right? So I've gone ahead and I moved this to here. Now I have an outside bracket, or an outside exponent. I would bring that in now. And I would get negative 8 x to the 6th, y to the negative 24th, and z to the 36th over 4. Why is it 4 even though the base is negative? Because it's inside the brackets and it's getting squared, absolutely. X to the 10th, y to the 6th, and z to the 16th. Now I would look at this and I would see, what can I deal with? Well, I can deal with that. That gets me negative 2 in the numerator, because 8 divided by 4 is 2. 6 and 10, those 6 will disappear. How much of those will disappear? 6 of them, leaving me with how many? 4. So I would have x to the 4th. What is wrong with that? It's negative. So where does it have to go? To the other spot. Because if it was negative down here, we'd move it up, right? So now this is going down here. Now I have 6 and 24 in the denominator. So what is it? Y to the 30. And 16 and 36. Where is the canceling going to occur? The bottom will all disappear, and how many of them will disappear? 16 of them, leaving me with z to the 20th. And that is done. There's lots of ways, other ways you could have done it. But at some point, you're doing all of these steps, just in a different order. Yeah? Yeah. Now, what about this fella right here? What do we know about that expression? What do we know about the fact that it's a negative exponent? So it's going to be 1 over 54 to the 4/3 now, right? Now, if you did that, you'd get some credit. Is that as far as we can take it? No, because you can do something with that. What do we know about the denominator? It becomes Sebastian said root, I say index. And what do we know about the 54? It becomes the radicand. And what do we know about the 4? It would be out here, right? Now, here is where it gets dodgy. Because some of you will simplify this and then put it to the 4th power. Some of you will remember that I said, if this doesn't work out perfectly, and it doesn't, does it? Because 54 doesn't have a cube root, you can bring that 4 down there. Now that means the radicand here is now 54 times 54 times 54, isn't it? Times 54, isn't it? And isn't that a group of 3? So what can I bring out of here right away? 54, and I left a single 54 under there. And now that is super easy to Simplify, because that's 27 times 2. What's the cube root of 27? 3. So what's coming out here? 3. And I get 1 over 162 cube root 2. Now, what I was saying would make your life difficult was if you did this. Which 3? That 3 right there? Because that's the cubed root of 27. Now, where the issue could happen here is if you simplify this to 3 cube root 2, then you've got to put all that to the 4th. And then you might be in a bit of trouble here. Right? Like that could cause you grief. Because I haven't reminded you how to multiply radicals yet, which is what we will be doing on a couple of days from now. Because, of course, why would I start with multiplying radicals? You got to start with adding and subtracting. Same way you were taught math with real numbers, with integers, I lie, with natural numbers in grade 3. Right? Right. So is everybody ready to go forward? Excellent. You will be having a test on exponents and this part of radicals, because that part is really based in exponents, tomorrow. I feel it only fair to warn you, I am going to expect you to do the multiple choice without a calculator. No. There is something like 17 multiple choice questions and 10 open-ended questions. I'm giving you 80 minutes to do 27 questions. That's 3 minutes per question. If I were to sit right here and start a stopwatch for 3 minutes and tell you, close your eyes and sit down, stand up when you think 3 minutes has passed, it would feel like a million years. No, because I've already done the experiment many times. And every time it happens, kids stand up at like a minute. They're like, I have to be 3 minutes. And they're all standing up. Try it on your own time. Find yourself 3 spare minutes. All right, let's go, cabbages. I know the joke doesn't work when I use the contraction, but it's still funny. All right. I can't remember the name of that font, but it's pretty sassy. It's kind of piratey, I think. So this is like page 37, maybe? Right. Oh, I suppose I should take a moment and make sure everybody did well with page 35 and 36, because that was technically your homework. So, very quickly, here are the right answers. There is 35. Check your work. Ask a question if you need to. There's 35. AB. There is CD. Everybody good? A little 3, because it's cube root. It's got an index of 3. Everyone is good on 35? E goes very slowly. There's E and F. 8 root 6 and negative 12 root 5. Yeah? No. This is radicals. This is on your next test. Everyone is good? There is the 2 answers you need for number 7. What do you mean? You want me to go through it? But it's all right here. But it says S is the half perimeter of the triangle and A, B, and C are the sides. So I gave you them. The sides are 8, 10, and 12. So the perimeter is 8 plus 10 plus 12, which is 30. S is the half perimeter. Half of 30 is 15. So it's 15 times 15 minus 8, 15 minus 10, and 15 minus 12. 753. And then I broke 15 down into 3 and 5, and I saw that I had a pair of 5s and a pair of 3s. So I brought them out. 5 times 3 is 15, and I left the 7 under there. When you're doing it as an entire radical, you've just got to remember that if there's one 15 out here, how many 15s are under there? 2. So this is 7 times 15 squared, which is 1575. I know that you've never seen that formula before, but you all should have been able to read it because it says what everything is. And then I ask you to simplify the following. They are... Wait a moment. That doesn't have an answer there for C. So C is 18 times 10, which is 9 times 2 and 2 times 5. So bring out a 3, bring out a 2, that's 6, so that's 12 root 5 over... Oh, I did have it. It's negative 4 root 5. It was there. I just didn't highlight it. So please check A, B, C, D, E, F, G, H. Check your work. Ask if you need to. D. Certainly. So 32, or 320 is 32 times 10, yeah? And that is 16 times 2, yeah? And that is 2 times 5, yeah? 16's got a square root of what? 4, so I bring out a 4, then a 2, right? 2 times 4 is what? 8. 8 times 1/8 is what? 8 times an eighth is 8. 8 times 1/8 is 1, so the whole front disappears, and what's the only thing left? A root 5. I do not like that color. I am getting rid of it. Answer.
It said that it wanted us to like go in and out of town.
Where?
No,
what one?
I forget. I'll ask when we
Okay. A, B, C, D, E, F, G, H are all good then? Otherwise? And then, I didn't do J and K for some strange reason. Weird. Of course, that is 98 times 10, which is 49 times 2 times 2 times 5. So you bring out a 7 and a 2, 14 root 10. Because you probably... It is because it is 14 root 5. That's why you got 14 root 5, because you did it right and your math teacher's a doofus. Could I do? Certainly. 304 breaks down into 2 and 152, which breaks down into 2 and 76. Which breaks down into 2 and 38, which breaks down into 2 and 19, and then it stops. There's a group of 2, so out comes a 2. There's a group of 2, so out comes a 2. 2 times 2 is 4. 4 times 5 is 20, so I have negative 20 over 6, root 19. Now, would Mrs. Bad Crumble ever let you leave that as a fraction? No. So you would break it down into negative 10 thirds root 19. And K, 2 and 136. Okay. 5 doesn't go into that. It ends in 2.
Oh, no, that's an 8. It's 8.
8 and 34, which is then 2 and 4, which I will stop at because 4 has a square root. 34 is 2 and 17. Bring out the square root of 4, which is 2. Bring out this 2, which is 2. 2 times 2 is 4. 4 times 4 is 16, root 17. And negative 36 root 2, and there is MNOP.
It's also a dumb question. P that you just left it, is it because it can't do anything?
Doesn't get any simpler.
Okay. I want to make sure.
It's cool. What? 123 times 3, which breaks down into 3 and 41. So I bring out 1, 3, and there's a 2 out there. So it's 6 root 41. If you need to. Toj. There isn't one. You get no retests. Every 2 units, you get a midterm. And you have to do better on it. If you don't, you don't. You get the better mark. You should get the midterm mark, even if it's worse, because you've had more time. But apparently that is too tough on you guys. So, you kind of are. Sure. But it's right there. 45 and 10, 9 and 5, 5 and 2. Square root of 9 is 3, so I brought out a 3. Then I bring out a 5. 3 times 5 is 15, times 2 is 30 over 5. 30 divided by 5 is 6. Did you leave it as 30 over 5?
I just don't understand when you're like, there's 9, take out, there's 5, take out 5. Okay. Do not answer this question with the first thing that is going to come into your head, okay? Don't do it. What is the square root of 4? I'm not saying.
I know, because the first thing that jumped in your head is 2, because you have it memorized, right?
Yes,
okay. The square root of 4 is really the square root of 2 times 2, right?
Yeah.
There's a group of 2, so we bring it out. There is nothing left under there. So it is 2 square root 1. What is the square root of 1? It's 1. 2 times 1 is still 2, right? Do we ever write 2 times 1? Do we ever write the 1?
No.
Okay, so you understand this, right? Yeah. Okay. What if I wanted the square root of 12? Well, that is the square root of 4 times 3, isn't it? What is the square root of 4? You already know that. A 2 comes out, and you left that 3 there.
Oh, that makes sense.
You're right. I hadn't shown you that before, to be fair. So possibly this is my fault. Yes. Hey, fortunately, there's all the video proof that I had never shown you that, so you're totally in the right. I know. All right. Shall we move on?
Yeah.
Okay. Page 2. No, what am I saying? Jump to page 200. Page 37. Oh, I believe there's 255 or something. Don't be that way. All right. Now, ladies and gentlemen, what we are going to do right now, you learned in the 9th grade. Okay? Probably before the 9th grade. So everybody feel strong because you all got through grade 9 math. Okay? Here we go. Don't. Hello? She's not here.
She's not here today.
But you would be welcome to, were she here. She would be all yours.
Oh, thanks a lot.
No problem. Okay. Everybody ready for something that you know how to do?
Yes.
Okay. Somebody say a letter.
Hey.
Okay. 5a plus 3a equals what? Holy crap. I'm not fooling you. What you think the answer is the answer. 8a. Okay. 3a minus 9a. Negative 6a. Okay. All right. Here we go. 4. Oh, wait. I want to change colors. 4b. Plus 3b. Okay. 8b minus 16b. Negative 8b. Okay. All right. Okay. Good. Yeah. All right. Here we go. 5a plus 3b. Oh. No. Stays the same. Why? A and B are different. Those are not like terms. Everybody remembers this now?
Yep. Why don't we start with this?
No, you cannot. Do you all remember this now?
Yes.
Not Bea, apparently, but everybody else. You can't add different letters. Everyone remembers this, right? You have heard your previous math teachers a million times say, collect like terms, right? And you know what a like term is. It is the same variable. Everybody cool? All right, so now let's just mess with this a little bit. What would happen if I did 5a plus 3b plus 4a plus 2b? What would that result in?
9a plus 5b.
9a plus 5b. Is everybody cool? Okay. What about this? Can you do that? No. Why not? Because they're not like terms. Those aren't the same thing. What if I put the 2 there? What's that answer now? 7 x squared. Because we're adding, so the exponents stay the same. Is everybody good? All right. So you all remember that this expression, ax, means a times x, right? A is what we call a coefficient, which we've already used that word this year again. And x is what we call an argument. Now, anything after a coefficient is an argument. And the coefficient multiplies the argument. Is everyone cool with that? All right. Now, if we are going to add and subtract, to add and subtract, our arguments must be what? The same. Highlight that. Please notice, A and A, it works. B and B, it works. A and B doesn't work. A works with A, B works with B, and we get both of them in the answers. Does everybody remember that? Excellent. It is the exact same thing with adding and subtracting radicals, except that instead of that being A, it's root 7. So if this was A, is that another A?
Yeah.
Is that another A? Is that another A? That's a B. So this would be exactly the same as saying 5A minus 3A minus 4A plus B. And then you would just add up the coefficients. Everybody with me? So what we're really doing here is we have 5 minus 3 minus 4A. But it's not A. What is it? Root 7 plus root 2. What's 5 minus 3 minus 4? Because I have a 5 and then a minus 3 and then a minus 4. I'm not sure what you're asking me, Bea. Because if you understood this with the A's and B's, I'm just showing you this is exactly the same thing. So 5 minus 3 minus 4 is negative 2 root 7 plus root 2. Can you put them together? No, because they are not the same. It's like they were an A and a B. Is everybody good?
So you leave it like that?
Yes. Okay. Now, if you have not been paying attention to the previous lessons, you would look at this and say, I'm done. I can't do that because they are not the same, right? But of course, you would never leave these like this. Why? Because we simplify when every single math expression for the rest of your math career, anytime you can simplify, you simplify. So what does 32 break down into? I would use 16 and 2. Why? Because 16 has a square root. What is the square root of 16? 4. So what comes out here? 4. So I have 4 root 2. What does 8 break down into? 4 times 2. What's the square root of 4? 2. So I bring the 2 out here and I get plus 2 root 2. Now, what do you see? They're the same. So it is 4 plus 2 root 2, which is 6 root 2. Does everybody understand how to add and subtract these? Please notice there has been absolutely no new math concept to do this. You are doing adding like terms like you learned in grade 9 and simplifying radicals like you learned in grade 10, right? There is nothing new here. You just have to put it all together in one spot. Okay? So what are we going to do with this? Simplify, because we can. What does that become? I would use 4 and 7. Why? 4 is a square root. What does that become? 9 and 7. Anybody know what that is? Probably not with a perfect square, so you might go 2 and 56. Right? Maybe. And then you might go 7 and 8, right? And 8 is 2 and 4, and then I can stop. Because you see, there is a pair, 2's, and I have a square root of 4. So what comes out of the first term? Sophia, what do I bring out of here?
2.
2. What's already out front?
5.
What do the numbers out front do?
Add together. Multiply.
10 root 7. What's coming out of here? 3. What's already out there, Haley? No. This one. We're doing the middle one now.
3.
So what do the numbers out in front do? So what's 3 times 3?
9.
Excellently done. Minus 9 root 7. What's coming out of here?
a 2, because there's two 2's, and another 2. What does 2 times 2 times 2 get me? Plus 8 root, what did I leave under there? 7. 10 minus 9 plus 8 root 7. What's the answer? 9 root 7. Because 10 minus 9 is 1, 1 plus 8 is 9. Nothing new, right? Can we do anything with D right now? We can't subtract them until we simplify it. So what's this? 4 times 5, right? Now, hold up. Bea said 2 and 10, no problem. Then 2 and 5. There's your group of 2. So what comes out? 2, what stayed under there? 5. 45 is what? 9 and 5. What's the square root of 3? What's the square root of 9? 3. What comes out? 3. There's already a 3 there, so what is it? Negative 9 root, what did I leave there? Now I have the same radicans, yes? Exact same arguments, so I just deal with the coefficients. 2 minus 9 root 5. What's 2 minus 9? Negative 7 root 5. And that's it. That's how you add and subtract. Now, let me ask you this before we go further. Because, oh no, I do have a few more. Good. Oh, never mind. Good, good, good. Yeah, I'm going to cover this in a minute. So all of you should be able to do 2A and B by yourself right now. You go. I'll do it here with the screen off, and then you can compare. Okay? But I will keep it recording, so if you watch the video, you will see me doing all the steps. Just without the dulcet tone of my voice. Because I know that none of you would dream of muting it while you watch the video, because you don't want to hear my voice anymore. You wouldn't ever do that. I do that. I don't like to hear it. Now, ladies and gentlemen, when I do 2A and B, I'm going to break the numbers down completely. I'm not going to stop at perfect squares, so you can see the longest possible way to do it, okay? Are you done? Just 2A and B. Okay. 2B. Huh? No, that was nowhere near 6 minutes.
How long are you giving us?
You should already be done.
I'm done, babe.
Okay. Me three. I love that joke from Scooby-Doo. That's too bad. Scooby-Doo is good comedy. Yep. Scooby-Doo is good stuff. How else would you learn that take a bunch of straws, stick them together, put gum on the end, reach in and pick up the keys? They were always dropping keys. They were all using gum to get the keys back. Wouldn't work now, though, because gum isn't sticky like it used to be. Check your work. The answers are highlighted in blue and green with all the steps. It's a 9 and 7.
I did 3 and 21.
Okay. Then you broke 21 down into 3 and 7. You still took out a 3. Again, the factor trees don't matter because you end up with the same factors. Is everybody good? All right, now. Do you think anything changes when we go to cube root in our methods? No. We are still going to simplify and add together anything that ends up with the same radicand, right? Except instead of looking for groups of 2 now, what am I seeking? Groups of 3. So 108 happens to be 27 times 4. Right? I chose 27 because 27 has a cubed root. I could continue to break it down and you would find that out. But in the interest of time and giving you more time to practice and or study, I'm going to stop on this one when I get to the roots I can stop at. Okay? So that has a cubed root of what? 3. So out comes a 3. There's already a 3 there. So what does this simplify into? 9 cube root. What's going here? 4. And you're done because some of you will bring out a 2 there, but it's a cube root of 4. You cannot. This is 8 times 4. Why did I use 8? It has a cube root. So what is coming out? 2. There's already a 2 there. So this becomes minus 4 cubed root 4. And 256 is 64 times 4. And I chose 64 because I have it memorized. The cube root of 64 is 4. So what comes out here? 4. 4 and 3 give me 12 cube root 4. Are all of my arguments the exact same? So that's the same as having 9x minus 4x plus 12x, right? So I can put them together. 9 minus 4 plus 12 cube root 4. 9 minus 4 is 5. 5 plus 12 is 17 cube root 4. Now listen to me carefully. You must stop and ask if you cannot follow A, B, and C. You have to. I don't care how embarrassed you think you will be. You have to ask because you can quite plainly see the next question is an obvious ass kicker. So you must ask now. I'm going to quietly wait a moment to see if anybody asks while you let this percolate through your brains. I'm going to take a nervous sip of coffee. Even though my coffee is gone, you all know it. I'm just doing this to pass time. There hasn't been coffee in that since like 9:30. Is everybody good? All right, now, listen carefully. This looks scary because you see fractions, but it's not. This is easy to deal with, right? I got that in the numerator, I got that in the denominator, no problem. This doesn't look like this, but is exactly the same. This is 9 cube root 48 over 2 plus 3 cube root 162 over 4. The 3 stays in the numerator, minus 3 cube root 750 over 5. Now, options. Remember, I have been warning you daily since this class started. You must bring every bit of math knowledge to the party. I am adding and subtracting fractions. What must I have? Pardon me? Oh, no. I must have the same denominator. What is the common denominator here? 20. So everything is going to be over 20. How did this get to be 20? Times 10. So what has to happen to the 9? So what do I have now? 90 cube root 48 plus, what did I have to do to this one? Times 5. So what do I have to do to 3? To get 15 cube root 162. Yes. What did I have to do to this guy? So what do I do to this guy? Minus 12 cube root 750. Just like it would only affect the 5 in 5x over 2 plus 3x over 6. We would only affect the coefficients. Now, why is that showing? That's the grade 3 part of this question, yes? Adding fractions. I need a common denominator. Miss Bag Crumble taught me that, no problem. Now, what are you going to do? I don't know what to do, Mr. Ryan, it's so hard. Step by step. What would you do if there was nothing on the screen except that? You'd simplify it, right? And that is 8 times 6, isn't it? I'm choosing 8 because 8 has a cube root, right? So what's coming out? What? 2. There's already a 90 there, so I have 180 cube root 6. Everyone agree? Finish up the numerator. How? Everyone should have been able to get to here. You're not going to get there as fast as I can. That's okay. It's not a race. It is exactitude we seek. Does everybody understand how I got my numerator? Now, what do you know? Oh, I wasn't going to go any further. I just need a little more room down here. What do you notice now? They're all the same. So are we allowed to put them together? So I have 180 plus 45 minus 60 cube root 6 all over 20. That gets me what? 165 cube root 6 over 20. Would Mrs. Bad Crumble let that fraction live? What would we simplify that to? What number goes into 165 and 20? Why? Why do you automatically know it is 5? Because the number ends in 0, the two numbers end in 0 and 5. So this divided by 5 is 31. 1 cube root 6 over 4. 31 and 4 gets no simpler. That is done. 33. Regardless, it gets no simpler. Yeah, it's 31 would have been 155, not 165. Anything new? No. But we are bringing grade 4, grade 9, and grade 10 all together in one question. Is everybody good? All right. So 39 and 40 are your homework. When are they due?
Tomorrow.
No, because what's tomorrow? Test. Okay. Now, you are on your own time for the next 20 odd minutes. If you wish to review exponents, go ahead and do so. I will walk around and offer assistance. If you wish to work on this, so you have no homework tonight or tomorrow, work on this. I do not care. It is your time. When you come in here tomorrow and write your test, if you finish early and these pages aren't done, what will you do the second you put your test on my desk here? You will go back to your desk and silently work on this until everyone in the room is done. Because you got silence for your test, they deserve silence for theirs. Okay? Because for some strange reason, teenagers only care about fairness when it's unfair to them. They're allowed to be unfair to everyone else. But if somebody is unfair to them, that's not fair. Which are 3 words in the English language that I think should never be allowed to be put in a sentence together anymore. But for some strange reason, they are every teenager's favorite 3 words to put together. Just like my favorite 4 words to put together is, I told you so. No, because I do care. If I didn't care, Prab, I wouldn't do all this stuff I do. I would do this super fast and say, there, I'm done, go.